Welcome to my EECE 474-375 exit tutorial. I am going to give a brief overview about the motor driver circuit using an H-bridge. To move your robot, it is essential to have motors. A common type of motor used in robots is the DC motor. It converts electrical energy into mechanical energy, which moves the robot. When a motor is connected to power, the shaft will start to rotate. Motors need a lot of power and current. It cannot be driven by just an Arduino or microcontroller. Hence, we need an H-bridge motor driver. The H-bridge is a chip that can control a motor to rotate in both counterclockwise and clockwise direction. Here is a simplified version of the H-bridge circuit, controlling one motor. 12 volts goes across the motor when you close switch 1 and switch 4. The motor will start spinning in one direction, say clockwise. Now, if you close switch 2 and switch 3, the motor will turn into the opposite direction. When all switches are open, the motor does not move. If you close switch 1 and switch 3, the motor will halt. This is the H-bridge L293D chip. It can drive two motors in clockwise and counterclockwise direction. One feature is that protection diodes are embedded within the chip itself. First, I will show you which pins will drive the motor. Pin 1 and pin 9 are enable pins. Each pin enables half the H driver on each side. To drive the motors, these enable pins are set to high. I will just focus on driving one motor with the left half of the H-bridge. If pins 2 and 7 are low, the motor is stopped. If pin 2 is high and pin 7 is low, 12 volts goes across pin 3 and the motor moves counterclockwise. If pin 2 is set low and pin 7 is set high, then 12 volts goes across pin 6 and the motor turns counterclockwise. If both pins 2 and 7 are both set high, then the motor will break. These are the rest of the connections. Pin 16 is connected to the power pin from the Arduino, which can be arranged from 4.5 volts to 7 volts. Pin 8 is connected to an external power supply, since motors draw a lot of power and current. The motors used in my project operated at 12 volts. As discussed previously, this is the truth table for controlling the movement of the motor. I will now give a simple explanation of the code used to control the motors. Each motor has 2 input pins and 1 enable pin, so 6 pins are dedicated in total for 2 motors. Because the pins read high and low, they are connected to digital pins or the Arduino microcontroller. In the setup part of the code, the pins are assigned as output pins and the enable pins are written to high. In your loop, you can choose when you want your robot to move forwards, backwards, left, or right. The functions used to move the robot is just a matter of setting the pins high or low. This is the code we used in our project for the robot to move forwards and backwards. This is the code we used to move the robot left or right. This is the code used to brake the robot. This is the end of my tutorial. Thank you for listening.